Hey there! Today we're diving into a fascinating problem related to Python's internal string representation. Picture this. You're playing around with different string lengths and noticing some unexpected memory usage patterns. The problem arises when you realize that a string with a single non-ASCII character takes up more space than a longer string containing the same character. Quite puzzling, right? Now let's delve into the solution that sheds light on this mystery. By peeking under the hood, using a snippet of Python code, we uncover the inner workings of string objects. Through a closer inspection, we discover that the varying memory usage is attributed to the way certain strings are statically allocated in their representation in memory. It turns out that specific strings, like O, have multiple representations stored, leading to slight discrepancies in memory consumption. Continuing with our exploration of the solution, we zoom in on the detailed output generated by the provided code snippet. Each line of output unveils crucial insights into the length, memory size, and internal properties of different strings. By dissecting the data, we uncover how the encoding scheme and the presence of special characters impact the memory allocation for each string. It's truly fascinating to witness how Python optimizes memory management based on the string content. In summary, we've embarked on a journey to unravel the intriguing behavior of Python's string representations. The interplay between string content, memory allocation, and encoding schemes has presented us with some unexpected outcomes. As we wrap up, remember to subscribe, like the video, and drop a comment below. After all, GNU strings could hold such hidden surprises.